Welcome to this lesson on selection structures. After viewing this lesson, you will become familiar with single and dual alternative selection structures, common comparison errors, interval boundaries and gaps, avoiding divide by zero errors using decision structures, swapping variable values, string concatenation and line breaks, comparing strings, and pseudo-random numbers. Let's begin our exploration of decision structures using a single alternative decision structure, and we'll find this in the Somerset Day Spa problem statement. So I've recreated the problem statement here, and the problem here is we're going to create an application for the Somerset Day Spa that accepts the number of persons that are in a day spa party and displays the total cost of a 3-hour spa party. So the cost starts at $195 a person, and it includes all these great and wonderful things. And we get a 10% discount for parties of more than 6 participants. Okay, so if it is not 6 or more, but if it is more than 6, which is to say 7 or greater, but we can simply say greater than 6. Okay, so let's begin our analysis with a classical IPO decomposition, input, process, output. And I find it sometimes helpful to start by color coding the problem statement. That can help you to identify the pieces that belong in inputs and outputs and processes. Remember that many times inputs are going to be repeated as outputs, but we're going to neglect that. So let's come through here and identifying the inputs. Let's set those to green. So create an application that accepts, oh, there's a keyword that kind of tells us that's going to be an input. It accepts the number of persons in a party. So number of persons in a party. And let's change the background color there to green. That's an input. Okay. And displays the total cost of a 3-hour spa party at the Somerset Day Spa. So displays is a keyword that kind of tells us, well, that's going to be an output. And what we're talking about here is the total cost. So let's use like a traffic light kind of thing. Inputs will be green. The final result outputs will be red. And then we may not get an exact statement in the problem statement of the calculation we need to provide, but we can identify the components of the processes of the calculation. So let's reread this again. Create an application that accepts the number of persons in a party, and certainly that will be used in that calculation, but we've already tagged that as an input, and displays the total cost. Well, that'll be the result of our calculation, but we've already tagged that as an output of a 3-hour spa party at the Somerset Day Spa. The cost per person, $195. That's certainly going to be in the mix. So let's mark that as yellow, which includes a 1-hour facial, a massage, aromatherapy, pedicure. Great, all that's good information, but it isn't part of stuff we have to process. The spa offers, 10% discount for parties of more than 6 participants. That's certainly going to belong in our calculations. Very good. Okay, with this in mind, we can start to identify and provide variable types and names for our inputs and our outputs, and then figure out our processes. Okay, so for our inputs, we need number in party, call it num in party, and we can never have a fractional person, so that's going to be an integer data type. And then what we're going to end up with, output, is total cost. That's going to be a decimal number, and after we do things like discounts and things, that certainly might be dollars and cents, so it's a fractional number as well, so it's not going to be an integer. We need to make it some type of real number so it can have a fractional portion, so either a decimal, a float, a double. Let's go ahead and use decimal here. Remember, in our flow charting tool, it just denotes them as real, so it's not until we get to the actual VB code that the decimal type is going to be supported, and that's all okay. And then let's see here. We need to do a couple different things in our processes. We could state this as one single process. I think it's more useful to kind of break it down and say the first thing we need to do is the decision. We need to decide the discount rate. So the discount rate is going to either be 0 if we have 6 or fewer people, or it's going to be 10% or 0.10 otherwise. And then let's see, what's the other thing once we have our discount rate? Well, then we need to calculate what the total price is going to be to charge the party. And so the other process, we're going to calculate total cost. And we already know that total cost is a decimal. And that's going to be num in party, which we already know is an integer, times 195, which is there's that component. And it's going to be one way to calculate this is multiply that by 1 minus the discount rate. So 1 is like 100% less 10%. That's going to tell us we're going to charge 90%. So we could also get fancy and just say 90% or 0.90, or we could even break this down and say first calculate the total cost without the discount, then determine the amount of the discount and subtract the amount of the discount from the total cost, and then that's the net discount rate. All those are equivalent. Hopefully you will see that any of those methods of calculation or orders of calculation result in exactly identical results. They're all equivalent. So this is my preferred way to do it this time. So 1 minus the discount rate. And there we go. So I have now identified my inputs, my process, my output, and we can begin to code up our flowchart. So here's a blank flowchart, and keeping that information in mind, we can start, as we always do, with our declarations. Okay, so let's see here. Save a little typing. I'll bring them in this way. Okay, so we have our number in party as an integer, our real data type discount rate. The discount rate I'm going to initialize to a value of 0, and that won't change unless we have a party of more than 6. So the discount rate will already be set up, so our decision won't have to process, what to do if the discount doesn't apply. We only need to determine what happens if the discount does apply, in which case the discount rate is going to change. And then we need the result, which is going to be a real valued total cost. Okay, so then the next thing we need to do is we need to prompt and accept that input according to our narrative. And so I need the output to prompt the user for give me the number in the party. And we're going to input that and store that in the num in party variable. And then we need to make a decision. So here's what our decision is going to look like. So do we have more than 6 in the party? If there are more than 6 in the party, then the discount rate is going to be 10%. Otherwise, we do nothing. So this is what makes it a single alternative. If this branch wasn't even there, this false branch, there's no processing done on that, nothing is going to change. We sometimes call that a fall through programming. So it doesn't change anything. There's really no action. So that's what makes this a single alternative. We're only really doing something if it's true. Otherwise, we just go on to the next instruction. And so by the time we get here, the discount rate will either be 0 if it's 6 or fewer people, or it's going to be 0.10 if it's more than 6 people. So that's going to set up our calculation to be correct. Now we could, and the book often shows you, I think, doing calculations right in the decision structure, but anything that is going to be done the same way on either branch, I just put right out here at the end. Don't make them an internal part of the decision structure. That makes our decision structure very pure. The only thing we have to decide is the discount rate, and we have one decision to decide the discount rate. Once we have that, discount rate is going to be going into our calculation no matter what, even if it's 0. And let's see how that works. Okay, so the total cost is the number in the party times $195 times 1 minus the discount rate. So if the discount rate is 0, it's going to just multiply by 1. It'll be unchanged. So essentially no discount. You pay 1 or 100% of the going rate, which is $195 per person. However, if there are more than 6 people in the party, then the discount rate is 10%. So 0.10, that's going to calculate this out. 1 minus, 0.10 is going to be 0.9. So we're going to take 90% of $195 times the number of people in the party, which is going to be some number 7 or more. And then that's going to be the correct calculation. So that all works nicely, or hopefully it will. And now we need to create our output. And here we output the total cost for this party will be, then a $sign, and then we're going to concatenate the total cost to it. And let's run some test data. So if I run one person through, it ought to be $195. One person, $195, just as expected. Okay, let's run it again. If we have 10 people, instead of 195 times 10, which would be $1,950, it ought to be 10% less than that. So let's see if that works. And here it is. It's 1755. So yeah, just eyeballing that, a little quick sanity check without having to do all the math in my head. I know that that's discounted less than 1950. And let's see, 10% would be about $185 less. And yeah, that looks like we're in the ballpark. So looks like my code is working. And so now I have a working flowgorithm. I've got my flow chart, and we could end it here from now. In the next step, we'll have to figure out how do we turn this into a task object event oriented chart and build our GUI and bring our code in to make some working code. But here we have, again, the single alternative decision structure and a little fall through. And again, the reason that this works is we set up the default for our discount rate up here after creating the variable. We set it to 0, and then we change it only if there are more than 6 people in the party. We could also have set it up the other way. When you think about it, we could have set our discount rate is going to be 10%, and then we could change the logic here and say, well, we're only going to set it to 0 if there are less than 7 people, or 6 or less people in the party. So we could flip our logic. That would be the complement of that. It really doesn't matter either way. It comes out the same. The typical pattern in programming is let's take the most common situation and make that our default. So if by and large most parties are 6 people or under, then we'd go ahead and make the discount rate 0 by default and only apply the discount on those occasions when which are going to be less frequent when there are more than 6 people. Again, in a practical sense, it's going to work either way. All right, let's end that there then. All right, let's continue by taking the next steps in the analysis and design and development of our project. So at this point, we need to translate this over into a graphical user interface in a Windows Forms project. And to do that, it's easiest to have a task object event or toe chart. And so let's take our inputs, processes, outputs model and think about what that's going to look like in terms of a graphical user interface. And so let's see here. We're going to need to get the number of people in the party, and then we need to decide the discount rate and calculate the total cost, and then have somewhere to display that total cost. The click event of our calculate button will actually take care of that, making that happen. And so we won't really have an event, and the input, we don't tie that to an event. The main work is going to happen on the click, and that's going to happen on our calculate button. Call it button calc. And then let's see, let's name this similarly to the variables that we've used. So let's call this text num in party. We'll use a text box to collect that. And we can also use a text box to display this. We could use a label. I think the textbook author prefers to use a label. I use a quick and dirty trick, which is to use a text box. And then if you don't want people to monkey with it, we can disable the text box so it doesn't accept any edits. So let's call it text tote cost. Okay. And with that in mind, let's go ahead and create a new Windows Form project to receive this. And so this will be a new project. And under Visual Basic, Windows Desktop, it's going to be a Windows Forms.NET Framework project. And, oh, this is the Somerset project. So we'll go ahead and call it Somerset. All right, and based on our toe chart, we're going to need one button, and we're going to need two text boxes here. One and two. And of course, it'd be better if we have some sort of indication of what those are. And so let's have a label for the first text box and a label for the second text box. And let's think about this. So maybe we'll do this, lay this out left to right. This time we get an input, then we expect the user to click the button, and then we get a result. Maybe that's a good layout. Horizontal layout, maybe we'd be better off with a vertical layout. That's a design decision you can play with. And maybe on our form, just to be nice, let's go ahead and take the time to make the text of the form Somerset Day Spa. Okay. All right, so we're ready to make some useful names for this using our toe chart as a guide. Let's call this our input box. So let's change this over to call it text num in party. And this one we want to change to text tote cost. And here's my little trick of using a text box instead of a label if you don't want anybody to modify it, because it's going to be presenting results. The results shouldn't be editable. So we can come over here and just change the enabled to false. Great. And then our button, let's change a couple things on that. Let's change the text to something like calculate. And then let's give it a meaningful name. Button calc. Okay. And again, we have no code in here yet. Let's fix our labels and then we'll do a test run. And this label should say something like enter member in party. Oh, it's not the name, it's the text of the label we want. Sorry, I'm in the wrong property. All right, let's kind of line that up. Oops, didn't mean to do that. And let's change label 2, and the text can be total cost. All right. I'm just mouse happy today. There we go. Okay, let's move this over a little bit here. Maybe back that. Boy, my mouse is really hair triggered today. There we go. Back that off a little bit. Total cost. Not quite happy with the layout. There we go. All right, good enough. And again, we haven't put our code in, but let's hit F5 and see how this looks on the run. All right, so this user comes in, puts in the number of people in the party, hits the calculate button, and we've got our disabled uh, text box here that we can, even though it's disabled, just means I can't click on it, doesn't mean we can't display to it, and that'll be fine. So that looks like a pretty functional interface. Now we need to work on our code. So let's go ahead and end that run. Now, if we go back over to our original flowchart, bring that in. So here's our Flowgorithm project that we tested and was running. And we could export this as console code, but we really want a working GUI. But we're going to use this logic that it's built for us. And you don't have to do this. You could just use the diagram and then write your code by hand. But if you want to maybe get a little head start on things, we can come over here and look at the tools. Let's view the source code and go get our special template for this class. And here's our source code. So let's go ahead and copy it from the clipboard. And we'll set this aside. And now let's double click the click button here. Let's make a little bit of room. And let's just Control V and paste all that in. Now, let's clean some things up because there's going to be some things in here we don't need. For one thing, it's not going to be a module anymore. It's going to be inside the click event. So we can get rid of the import system, and we can get rid of the module definition, and we've already got the private sub-click event, so we don't need to have sub-main here. Let's get rid of that. There's our nice else structure, and then let's see. We're going to do our own inputs and outputs. We don't need a function for it, so let's get rid of that. And the other function for the input text and the function for the output text, and these comments are no longer needed, and we don't need the extra end sub. Okay, so Now what we need to fix is just the output and input statements need to be changed over for the GUI, right? The rest of the code, which is doing the if and else, and note that there's no false path on the string, we could actually get rid of that part of the structure. Let's leave it in for now. It's instructive. There's our calculation. And so what let's do where it did the input, we'll leave the variable declarations are just fine. We can reuse those. And so here we don't need this output at all because we don't have to provide a prompt. It's already on the Windows form. So let's just delete that. And num in party equals input value. Well, that's going to be a little bit different. What we really need to do is we need to take and to try and parse the input that was on the Windows control. Okay, so let's try parse. And it's going to be text box num in party dot text. Can we parse that into num in party? And let's see, what's the data type we're trying to type it into is, and it got converted. We had said originally a decimal, and we ended up with double. Double will work, that's fine. Let's use that. Double dot try parse, it's num in party, and then the rest of our code should work. So if num party, so now what we've done is we've parsed it out. If it parsed successfully from the input text box, it's going to be in our variable. We can do our calculation on our variable, and then we can come on down, we run our decision to determine our discount rate, and then based on whatever the discount rate is, we calculate the total cost. And now we need to fix this one output. Let's come over here and make a little room. And instead of output, we already have a text box for that. And so what we want to say is that the text box total cost dot text is going to be equal to tote cost, and let's cast that to a string rather than making it do it for us, which it would implicitly if we have the implicit pragma allowed. And we no longer need this console read key because we're not in a console environment, so we can drop that out. And a lot of work for a little return, so you might want to just type this code in by yourself rather than using Flowgorithm. But an example of how we can use the Flowgorithm to help us build the VB code or get started on it. So just to recap what we're doing, when the button gets clicked to do the calculate, it declares a variable num in party and a variable discount rate, and it's going to set the initial discount rate as 0, and then it's going to declare the total cost as double, and then it's going to try and parse whatever the user has typed in to the num in party text box, and if it's able to interpret that as a number, it will store it in the variable num in party. And then num in party is evaluated, and here's our decision. If there are more than 6 people, then you get a discount rate of 10% on the party, else nothing. Okay, so as I said, we could even delete out that whole else structure. There is nothing else for it to do, so that's, or we could leave it empty. And then it ends the decision structure, ends the if, and then it does our calculation, which is going to be the total cost is the number of party times 195 and times any discount rate. And again, if the discount rate is 0, it's just going to multiply it by 1, so it doesn't change anything. If the discount rate is 10%, then we're going to ultimately be multiplying it by 90%, So you pay a discount of 10% means the party pays 90% of what they would otherwise have paid. And then let's take the text cost and populate that with the value we calculated in tote cost converted to a string. And so that should be it. Let's go ahead and give it a try and see if our program runs. F5. And let's see, if I have 1 in the party, it should be $195. And it is. And if there were 10 in the party, we should see a discount. So it should not be, it should be something less than $19.50, right? And indeed it is $17.55. Very nice. Now let's explore a modification to the Somerset project that will require a dual alternative decision structure. So this last line has been added. So we knew that the SPA was previously offering 10% discount for parties with more than 6 participants. The SPA is also now deciding that it's going to offer a discount for smaller parties and individuals of 5%. So let's add that. Again, that's not an input. That's going to be just part of our decision structure and our calculations, our processing. And so we could go and update our IPO model. And I think in this case, we'll cut to the chase and go look and see how that is going to impact our code. So let's start with our logic and our design. And so here is our original single alternative selection structure, and there was nothing over in the false choice. But now we could say, hey, if it's more than 6, you get a 10% discount. And if it's not more than 6, the false part is going to be that you get a discount rate of 5%. And because of the clever way we set this up, everything else is going to remain the same because our calculation is going to use whatever the discount rate is that's supplied by the whole decision structure. And so it doesn't care. The calculation itself hasn't changed. And let's test that and see that that's running correctly. Okay, number in party. So if I have 1, it should be $195 less 5%. And that looks correct. And let's run it again. If I have 10, I should still get the 10% discount because the 10 is greater than 6. And in fact, I do. Very good. So that's really all we need to do is to modify the false part, the false path on the decision structure. So let's see if we can do that in our Visual Studio project as well. Okay, so let's go ahead and take a look at the recent projects. And here's the Somerset project. Let's open that back up. And let's go in and look at the logic for the calculate button. And you'll recall that I said we could just delete the whole else piece, but I left it in. And now I'm happy that I did, even though it was empty, because I can replace this whole comment, and instead we can say discount rate equals 0.5. Oh, 0.05. That's better. And let's test that and see if that runs. So I'll go ahead and hit F5. And the build and the run. And so now if I calculate 1 person in the party, oh good, it was 195 less the 5% discount, and that looks about right. And if I had 10 people in the party, I should get a 10% discount, and I do. So that's looking perfect. Just that simple. So let's, before we sign off, on this video segment. Again, let's look at the dual alternative decision structure. So if there's a true part, it does this. If there's a false part, it did this. And just to show you, because I haven't demonstrated that yet, back in our original version of the project, if we had chosen to eliminate the else structure is not required here. We can have an if and one alternative and the end if, and that is truly a single alternative. And let's go ahead and F5 and see it run. And one person, no discount, and 10 people gets the discount. So there it is with the alternative decision structure removed, no alternative path. So it's a single alternative decision structure. And again, all we have to do to add that back in, put our else clause in, and else change our discount rate to 5%, and we're good to go. Let's explore the comparison operators a little bit. And I'm not going to be so tedious as to walk you through the fundamental and familiar use of the comparison operators. But what I would like to show you is some very common errors that occur in boundaries when using a series of comparison operators. And I call these gaps and overlaps. So let's actually come in and make an error in our program logic design that is really common and really kind of insidious because it looks pretty good, and if you pick the right values for testing, it will work as you expect. But there are gaps in our logic here, and we'll see that as part of the design of the problem I set up. So our comparison operator scenario here is we're going to write an expression to determine the shipping rate. Packages that are 2 pounds or less have a rate of $7.50 a pound. Packages over 2 pounds but less than 5 pounds have a rate of $6.75 a pound. And packages that are 5 pounds or over ship at a rate of $6.10 per pound. Okay, so we've declared a variable. It's a real variable called weight. And I've best practice, I've set that to 0 and initialized it prior to use. I've got a shipping rate that we're trying to determine here, and that's going to be a real valued number. And I've also, following best practice, initialized that to 0 or a safe value before we start our program. And then we're going to output a prompt to the user. It says, please enter the weight of the package. And then we input that and we store the value in weight. And here's where our logic comes in. And here's where we're going to start to make mistakes. See if you can catch them. So I said, okay, evaluate the weight. If the weight is less than 2 pounds, then the shipping rate is going to be $7.50. If that's not true, it must be greater than 2 pounds. So we come over here. And if the weight is greater than 2 pounds and the weight is less than 5 pounds, then if that's true, then the shipping rate is $6.75. If it doesn't meet both of those criteria, because I used an and, then it will evaluate as false. And so that's got to be something that's over 5 pounds. So weight, I'll check and see. If the weight is over 5 pounds, then the shipping rate is $6.10, and there's nothing for the false part because this is my upper value rate. So I can leave that as an empty path. And then we come on down and we're going to output the shipping rate. Now, instead of just saying the shipping rate is and tell you what we determined, I put logic in here that we're going to need because at this point, is it possible logically that the shipping rate could still be 0 after we went through all that logic? It's not supposed to, but because of our logic errors, it might be. And so if we find out that somehow I managed to get down here and determine the rate is 0, I output, ouch, the shipping rate is 0, something went wrong. Otherwise, we'll just tell you what the shipping rate is. Okay, so let's run this with some nice good values that should be within our range. Okay, so we wanted to know what if it's under 2 pounds. So let's make it a pound. Well, that's 750. That's what it's supposed to be. Um, well, that's under 2 pounds. What about over 2 pounds? Let's run it again, and let's say it's 2.25 pounds. Well, that's looking beautiful. It's 675. Okay, it's over 2 pounds, but that's less than 5 pounds. Let's try something over 5 pounds. And so let's try, I don't know, 100 pounds. And everything works perfect, right? My program code is flawless and everything's beautiful. Yeah, not so much. Okay, so there are some gaps in my logic, and I'll show you where they are. So let's run this again. And what if I land exactly at 2 pounds? Ouch! The shipping rate is 0. Something went wrong. Wait, what gives? Is there another gap problem? Let's run this again. How about right at exactly 5 pounds? Ouch! The shipping rate is 0. Something went wrong. In order to more easily see what's happening here, let's borrow from the good folks at Mathway. Let's see, I've got the Mathway site up here. And let me grab my notes. I cribbed my notes here. So here's my notes on what we did. We coded up for the weight is less than 2, the weight is greater than 2 and less than 5. And we also said, well, what about the weight is greater than 5? So let's take that list of inequalities, drop it in here as a math problem, and let's tell it, graph it. And scroll down, let's grab that. And nice. So we see that the number line is nice and, oh wait, it's not continuous. There's a gap here at the value 2. There's another gap here at the value 5. Why am I getting an open circle? That's because the different ranges, the intervals, don't match up tightly, okay? And so I said, well, what if it's less than 2? And I said, what if it's more than 2? And I said, what if it's less than 5? And what if it's more than 5? But I didn't say what should happen if it is exactly 2 or it is exactly 5, okay? So what I really was looking for is not this coding. I'm looking for this coding here. What we really should have coded in the problem is if the weight is less than 2, or if the weight is greater than or equal to 2, and the weight is less than 5, and then the final interval is the weight is greater than or equal to 5. And let's see what that gap would have looked like, or what that graph would have looked like. There should be no gaps in it. So let's put this away, and let's put in that problem now, and let's graph that. Ha ha. Notice the closed circles. So I have no gaps in my intervals. Okay, so it's smooth and continuous. So if I fix that here, so I'll slide my notes off so I can see them on my second monitor here. And let's come back to our code. And what we wanted to say was, is the weight less than 2? Fine, that's fine. But what we wanted to say here is, well, actually, we want to know if the weight is greater than or equal to 2 and less than 5. And here we want to say, is the weight greater than or equal to 5? And I'm still not entirely happy with this last one. We'll come back and talk about that some more. But logically, that should be correct. So now let's go test everything. So does 1 pound work? Yes, it does. Does 2 pounds now work correctly? Ah, yes, it does. And then does 3 pounds still work in that interval? Yep. And 4 pounds? Yep. What about 5 pounds? Ah, that is now working. And 6 pounds, or we could even make it 100 pounds, right? Once we're over that interval. Yeah, so that's all working correctly, I'm no longer getting zeros and ouch, it's not calculated. It's all running correctly. Okay, so far, so good. Let's take a look at one other thing that we can consider. This is the interval of things, this divider here is things that are less than 2 pounds and everything else is over 2 pounds. And this is the interval of between, okay, between 2 pounds, including 2 pounds, and less than 5 pounds. Okay, the only other possibility over here, since this is our last interval, is that anything that is left over is going to have to be true. That's why we don't have to code this false part. So the question is, why even make a decision here? There's really no decision to be made. What we should really do is take this, put it here, and just get rid of this decision altogether. Okay, so now it's either in between or it's over. So it's below, it's in between, or it's over. And I think that that is much cleaner, even though the other logic is logically correct. I think this is a much cleaner way to code it. Let's check that again right quick. And so I've got one in the low category and it works. And I've got one in the mid category and it works. And I've got one in the high category and it works. And let's check right on my boundaries. Does it work at the boundary of 2 pounds? It does work correctly. And what about the boundary of 5 pounds? Yeah, that's working correctly as well. So that's all very good. And again, the continuity in the graph helped us to see that. So sometimes when you're starting to do the logic, or I don't care down the line, even an experienced programmer, when you're checking your intervals, it's sometimes helpful to go back to fundamentals and draw the number line graphs like we used to in elementary school math with the closed circle and open circle on the intervals. It's easier to see. Okay. The one place where it can still bite you and is still pretty insidious now that we've talked about filling the gaps is what about overlaps? What would happen, for example, if I overlapped it this way? So here I'm saying is the weight less than 2? What if I made a mistake here and said if it's less than or equal to 2? Now what's going to happen? If it's exactly 2 pounds, that's going to be true, and it's going to be $7.50. But is that supposed to be what it is? It's going to say packages weighing 2 pounds or less have a rate. So actually that should be, we were in error. 2 pounds should not have kicked me out at the 675 rate. 2 pounds should kick it here. But here's the thing. I have an overlap here. Weight greater than or equal to 2 pounds, weight less than or equal to 2 pounds. Oh, this is okay. That's not an overlap. We're all right. So less than or equal to 2 pounds, 750. And what is our statement? 2 pounds or less. So, okay, that is now corrected. I had an error in there I didn't even catch in my planning. Yeah, hoist on my own petard. Okay, so now this includes 2, so this should exclude 2. Why? Because if it comes in and it is right at 2 pounds, it is going to now take a right turn and go down here. This test is going to look for 2 pounds, and so it will never ever evaluate it. Okay, and that actually turns out to be okay because it was caught here, but there is an overlap. What if we had intended that this be, you know, the rate for 2 pounds? If we changed our problem statement, let's do that. So write an expression to package weighing instead of 2 pounds or less. Let's say weighing less than 2 pounds have a rate of 750-pound packages, 2 pounds. So we'll say packages weighing at least 2 pounds but less than 5 pounds have a rate of $6.75 a pound, and packages 5 pounds or over. Okay, so here, because we have the overlap, this one is going to be true and 2 is going to go this way, even though we wanted it to go this way. Okay, so this overlap actually here doesn't hide the error. This one actually expresses the error. So right at 2 pounds, we're going to come at 750, and according to this, even though this was coded correctly. Okay, so the problem is that we got diverted by the overlap here. The overlap was incorrect. We could also have a problem here if we were to say weight is less than or equal to 5 pounds. Okay, so now we have an error. There's no overlap because we took our other decision away. But let's put it back so we can see the overlap problem. So if weight greater than equal to 5 pounds, and let's go ahead and cut that and paste it right back in here. Okay, so now which did we intend? Which is supposed to, both of them are coded for 5 pounds, but the first order decision is the one, the comparison is the one that's going to express and control that. So what did we say for 5 pounds? Packages weigh at least 2 pounds, but less than 5 pounds. Okay, so the problem is now, if it's exactly 5 pounds, it should have had a rate of 610, and this is expressed correctly, but because of this, it's going to give it a shipping rate of 675. Let's see that that's the case. So let's go ahead and run this. What if we have 2 pounds and 2 pounds 750, and that's not what our 2 pounds should be. 2 pounds to 5 pounds should be in 675. What about the 5 pounds? Let's run this again. So right at 5 pounds, and we're getting 675, and that's not right. It should have been coming up at 610, but because we have the error here, and see that we have, both the value 5 is accounted for here and here, and so we need to fix these. So let's read our specification very carefully. This is really stuff that's really insidious, and it's also, as you might expect, when we're working with comparison operators in a beginning programming class, guess which test values the professor is going to pick to test. I'm going to pick in between the boundaries, above the boundaries, below the boundaries, and between the boundaries, of course. But I'm also going to test on the boundaries. And so if you've got errors in your code on the boundaries, either gaps or overlaps, I'm going to find them, and you're going to lose points for it because it's a really important error. It's actually the kind of error that would result in potential losses in business if we were doing fiscal calculations or charging customers based on these. So they're really, really important. It isn't just close is good enough. We've got to get it right. Okay, so less than 2 pounds should go to 750. So less than, not equal to. Okay, so weighing less than 2 pounds have a rate of 750. And so this is an error. Let's correct it. Now, less than, do we have a gap? No, because 2 pounds is now accounted for here. Now what about 5 pounds? Okay, less than 5 pounds at 675. So less than or equal to? No, that's not what we wanted. Less than 5 pounds. Okay, So if it is 5 pounds or more, now do we have a gap? No, because this includes 5 pounds. But in fact, because we are doing a single alternative decision structure here, we really don't need this decision structure at all. Everything that's left over by this point should get this rate. So again, let's move the calculation up here and just get rid of this decision altogether, and let's test. So right at 2 pounds, and I'm at 675. Does that match my problem statement? Less than 2 pounds at 750, but at 2 pounds, that's where the breakpoint is. I should get 675, and I do. Good. What about at 5 pounds? Package weight, 5 pounds, I pay 610. Is that correct? Let's go see. Packages 5 pounds and over have a rate of 610. Okay, so that appears to be working properly now. Okay, so also now that we are not going to have these errors, we don't really need to deal with this decision. We could simply take and cut that, put it right in line here, and we can get rid of that decision altogether. And now we have a nice, tight, correct program with nice watertight boundaries with neither gaps nor overlaps, and our code will work correctly. And just to recap again, you can come play with the Mathway site, put your expressions in here, and here's a problem that has a gap. Notice that we don't have anything to handle when it's equal to 2 or equal to 5. It's much easier to see now that you've become attuned to it. We run that and do the graph. And let's come down and let's look at the graph great big. And you notice that we have an open circle at 2, and we have an open circle at 5. So we've got a gap in there. We haven't accounted for it. It's a little bit tougher unless you graph it by hand to catch the overlaps. This one has no overlaps. Oops, I've grabbed the wrong problem again. Let's grab the correct expression of it. Nope, I got the wrong one stuck in my clipboard. Let me see if I can come fix that here. All right. Yeah, okay. So less than 2, on 2 to less than 5, 5 or more. And so now we graph it. We get a nice continuity, a nice continuous line here. Notice that the boundaries are inclusive, nice solid fill. And we need to double check by hand, make sure that we didn't overlap our boundaries, but it looks like our boundaries are watertight and abutting, nice and tight exactly on each other with no gaps. And that's what we want to see. One last run just to see it all working. Let's do a low value. Correct. On the boundary. Correct. Mid value. Correct. On the next boundary. Correct. And a high value, 500. Also correct. All right. So hopefully that is helpful in checking below, between, above, and upon all of our boundaries in a series of intervals when we're coding decision structures using inequalities and comparison operators. One of the concepts we're going to begin to study very closely fairly shortly is the idea of defensive programming. And defensive programming is good practice programming that says if there's a way that the program could break or be broken that we can anticipate, let's put in the safety code to protect the program so that can't happen, or if it happens, that the program doesn't just crash, that it at the very least, exits gracefully and hopefully gives the user some useful feedback about what the problem is. We do that in a number of ways. We're going to start looking at data validation. Data validation will do things such as if we're looking for a number, it won't accept text. If we're looking for text, it won't accept a number. If we're looking for text that needs to be formatted according to certain rules. For example, zip codes have to be 5 digits, not more, not less, can't include letters, those kind of things. We would build into our program the logic that would make sure that we only accept valid values, and if an invalid value is accidentally entered by the user, rather than having the program have an breakdown or crash, we just have the program say, stop, I'm sorry, Mr. User or Ms. User, this is not correct. Here's what the problem is. Please give me something I can work with and check your work, and I'll be happy to go on and be a computer program after that. And so we're going to do the same sort of thing here in protecting a calculation. And this is a common technique that we try and protect against dividing by zero. Dividing by zero, of course, over the set of real numbers is not defined. It's not a legal math function. So we need to stop when that happens. So we're going to detect that. So here's a simple program, and the problem statement is accept two numbers from the user, divide the first number by the second, and display the result. Note, warn the user if the denominator is equal to 0, as this is undefined for the set of real numbers. Now, I have not implemented that part of the code as yet, but let's see what we have so far. So we do our declarations. We're declaring a numerator, a denominator, and for the result, calling that variable quotient. And then we prompt the user, here's an output, enter a value for numerator, and then we accept that and store that to the numerator variable. Then we prompt the user for the enter value for denominator, and then we take an input and store that input into the denominator. And then we do our process, which is to say we're going to take numerator, divide by denominator, store the result in quotient, and then we're going to do an output of a little report. The output says the result of dividing, concatenation operator, numerator, concatenation operator by, concatenation operator, denominator, concatenation operator is, concatenation operator, quotient. So it'll say something like the result of dividing 1 by 2 is 0.5. Okay, that's all great and wonderful. And let's test our code and see where it's working and where it's not. Okay, so let's do exactly that. Let's divide 1 by 2, and the result of dividing 1 by 2 is 0.5. Well, that's all great and lovely, and we could play around with a whole bunch of valid values, but let's cut to the chase and test our code with something illegal. Now, we can say any number here. Let's say 5 divided by 0, and enter. And as soon as we do that, the program crashes and it says, division by 0. In mathematics, no number can be divided by 0, cause the expression 5 divided by 0 causes an error. Well, yeah, do you think? Pretty clearly it does. Okay, so what we need to do is we need to detect that we're about to divide by 0 and not let that happen. So what we need to do is insert a decision here. And we need to say if denominator equals 0, and if the denominator is divided by 0, let's do an output and warn the user. Oops, so sorry, but you cannot divide by 0. Program will now end gracefully. Okay, so if we're trying to divide by 0, it's just going to refuse to do it, and the program's going to end gracefully. Now, if we're not dividing by 0, then we can go ahead and do the division. So let's go ahead and move both of these, our process and our output report, let's cut them and paste them into the other branch of the decision. So if we're doing something illegal, we tell the user, nope, sorry, you can't do it. If we're not doing something illegal, then we'll go ahead and happily do the process we were going to do as we had originally planned and output the result. Now let's see if this works. So let's run and let's test with good values. 1 divided by 2 and 0.5. So everything is still working fine there. And what about this? Is this legal? 0 divided by 5. Well, sure, the numerator can be 0, so it says 0 divided by 5 is 0. Yeah, 0 divided by anything other than 0 is 0. 0 divided by 0 is not defined. And let's test that. Okay, so let's try something like 99 divided by 0. And now, instead of crashing, the program detects the error and says, oops, so sorry, but you cannot divide by 0. Program will now end gracefully. And we could also, if you think about it, we could also, once we start learning loops, we could loop back and say, you know, that value wasn't good. Why don't you try again? Okay, you still didn't get it right. Okay, try one more time. No, you still didn't get it right. And we could continue to prompt the user until they give us an expression that does not equal 0 for the denominator, and then we can go ahead and continue processing. So we aren't forced to have to end the program, but ending the program gracefully is always a better choice than letting the program crash. And so this is a simple example of how we can achieve that. A fairly common programming task is to swap the contents of two variables. We often do this when we're comparing the size of two variables and we want one variable specifically to have the larger value and the other variable to hold the smaller value. This is really common when we're doing things like sorting lists, and we would iterate through the list and repeatedly swapping the larger and smaller values. You do that enough times, you will end up with a list that is sorted from largest to smallest or smallest to largest, depending on what comparison that you use. And it's also a algorithm that beginning programmers often make a simple mistake with. So I've recreated a program to swap two variables, a smaller number and a bigger number, and to make that same mistake that is so common. And so let's take a look at the specification and then run through the problem that has the or the algorithm that has the bug in it, find the bug and fix it by way of better understanding how to correct it, what the correct procedure would be. So here's our comment containing our specifications. Accept two numbers from the user, store one in a variable named smaller num and the other in a variable named bigger num. If the numbers happen to be in the wrong variable, swap them so that the smaller number is stored in smaller num and the bigger number in bigger num. And print a report indicating the smaller and larger numbers, or state that the two numbers are equal if that happens to be the case. Okay, so really we've got three situations we're dealing with. One is when we get the numbers in the correct order, the smaller number happens to land in the small num variable and the bigger number in the bigger num variable, and we don't have to really do anything except report it. The other possibilities are that the two numbers happen to be equal, in which case we can't really claim that one is bigger and one is smaller. They're both the same. We should call that out. And the third possibility is that they're in the wrong order, in which case what we want to do is we want to take the contents of the first variable and put them in the second variable, and the contents of the second variable and put them in the first variable. And therein lies the problem. And if you were listening very carefully, I'll say it again, you may catch what the error is and in my programming as I described it. I'm going to take the contents of the smaller variable and put them into the larger variable. Then I'm going to put the contents of the larger variable into the smaller variable. Did you see the problem? If not, watch and it'll become clear as we go forward. Okay, so I'm working in Pseudo-Random so we can have a nice visual record here. And so I've called out a real number value, smaller num, a real number value, bigger num are both declared. and I ask the user, I prompt the user, please input the first number, and I put that into smaller num arbitrarily. I don't know at this point if it's going to be the smaller number or the bigger number, if the two numbers happen to be equal. Doesn't matter. I just need to get them into some storage variables to begin with. Then I say output, enter your second number, and we drop that into bigger num. Now we need to figure out whether we got lucky or if they are in the wrong order, or if they happen to be equal. So I have a decision structure here, and I say if the smaller number is less than the bigger number, which is the happy circumstances, I don't really have to do anything. That's true. I come over to the true part. My comment here is no need to do anything really, and so I just output the statement the smaller number is, and I concatenate that with the smaller number, and then I can continue the concatenation semicolon the larger number is, and put in the bigger number and concatenate that with a period. So we'll get a statement that would be similar to the smaller number is 2 and the larger number is 10, something like that. Great. Okay. If that doesn't happen to be the case, then I'm left with the two other possibilities. Either they're equal, or smaller number actually contains the variable smaller num contains the larger number, and the bigger num variable contains the smaller number. I need to swap the two. Okay. And so here's where I'm going to get into trouble, and see if you see it yet. So if it is true that the two are in reverse order, I'm going to take smaller num and I'm going to move into it bigger num, and I'm going to take bigger num and move into it smaller num. Did you see the problem? It may not be real obvious yet, but we just made the critical error. This program is not correct. Okay, we'll come back and see that in a minute. Once I've done that, I output the statement, the smaller num is in smaller num, and the larger number is, and I say bigger num, and concatenate that with a period. And so if it were working correctly, again, we would end up with something similar to the smaller number is 2 and the bigger number is 10. Okay, but this is not correct, and we'll see that when we run it. Now, the last case, the only remaining case, if the first is not bigger and the second is not bigger, then if neither is bigger, then the only remaining case is that they're equal. So I don't even really have to test explicitly to find out if they're both equal. That's the only remaining possibility. So I'm not even bothering to test for it explicitly. You could, it would kind of be a waste of CPU cycles to do the additional test. So I made a comment here, last remaining possibility, the numbers must be equal. We simply say both numbers are the same, and colon, and I concatenate it arbitrarily with smaller num to say what the value is. I could use either smaller num or bigger num here because to show you what the value is, because the two are equal. So I don't really need to use both, just pick one, doesn't matter. Okay, and at that point the program ends. So now I've claimed that there is a bug in this program. To really see it, let's run and then analyze what's happening. So let's go ahead and run the program, and let's start with the situation where the first number I enter happens to be smaller. So I'll put in 1, and I'll put in 100 for my second number. Great, it says the smaller number is 1, the larger number is 100, and that logic path worked perfectly. Fabulous. Okay, now let's run it again. This time let's make them equal. First number is 99, second number is 99, and it says both numbers are the same, 99. Okay, that logic path is fine. So where we're going to run into problems is my bug that is somewhere in this logic path here, which is the true part of the decision structure that says a smaller number greater than bigger num. So if that's true, here's where we're running into problems. So let's see it. So let's put them in backwards order. Let's make the first one 99, and let's make the second number 50. Okay, bam. The smaller number is 50 and the larger number is, wait a cotton picking minute, that would make them equal. What happened? Plus what happened to 99, because I correctly input 99. So let's go step through this and think about it. Okay, so sometimes it might help to make a little notepad or a little spreadsheet, something for your test values. I'm going to bring up Notepad, and I'm just going to make it kind of small so we can see it on the screen at the same time, and I'm put it along here. So if I had in smaller num So small is 99, and the bigger number is 50. Look what happens here. So the first thing that I do is I come along and I say, put bigger number into smaller number. Okay, so here's smaller number, and if I do that right away, so I've stored that in 50. Look what happened. I'm now in a state, since I haven't yet updated bigger, where smaller equals 50, bigger equals 50. What happened to my 99 value? I overwrote it. The one that was in smaller value just got overwritten. So what I need is a temporary value, and I need to move whatever was in smaller number out before it gets overwritten. Ah, now I see what's happening. Okay, because I'm accidentally throwing away one of my numbers before I save it. Okay, so I'm going to come over here and let's declare another num. And I'm going to call it temp num. Temp num is also going to be a real value, and we're going to use that to temporarily hold on to things while we move things around. So if we're going to swap, what let's do is first, let's assign to temp num smaller num. Okay, now bigger num can go into smaller num, which overwrites it. And instead of overwriting bigger num with small num, which now has the same value as big num, we're going to put this and say bigger num equals temp num. Okay, so it's like not having enough hands and you need to juggle something, so you have somebody else hold something for you for a minute. So smaller num says, hey, wait a minute, I don't want to, I'm holding the bigger number. I'm going to go put it into, temp num, come over here and hold the bigger number for a moment. Then smaller num takes a copy of the bigger num from bigger num, and bigger num says, okay, well now I can take the smaller num from temp num, who was holding the copy temporarily while smaller num got overwritten. Now everything should work happily. Let's see if that is the case. So again, first num, let's make it the larger, and second num, we'll make the smaller. And now smaller number is 50, larger number is 99. Now we're happy. Okay, so that's the trick to overcoming the error and working with a swap function. So in a swap function of swapping the values of two variables, we're always going to use a third variable, one more variable than the numbers we have to swap, so that we can temporarily put something so it doesn't get overwritten, and we can then recycle it back into the larger number or the smaller number, depending which one we're doing first. Are we swapping smalls for bigs or bigs for smalls? But ultimately, we need that one extra, and then our logic will work correctly. Let's take a moment and talk explicitly about something that I've been demonstrating implicitly in my examples for quite some time, and that is the concatenation operator. The concatenation operator is used to glue strings together. So if we want to continue a string in a text message, we will take the contents of a couple of different variables and glue them together using the concatenation operator. And along the way, while we're talking about the concatenation operator, let's learn a little bit more about some of the text box properties. We'll make some multiple lines, so we'll use the multi-line text box property. And the other thing I would like to touch on is line breaks in VB, and I'll show you an old school way of doing it and a new school way of doing it, and we'll talk about why the new school way is better and necessary. And let's just have at it. Okay, so I've got a VB form open here, and I've dropped in a text box that I've just called some text, and I've got a go button, and as usual, we'll put all of our code into the click event. So what I'd like to do is I'd like to put more than one line in the text box. But you notice that the text box, I can make it wider and narrower, but how about taller? And the reason I can't make it taller is by default, a text box holds a single line of text. But what if I would like to have multiple sentences, sort of a paragraph structure? I'd like to have them broken at the end of the line, maybe at a specific place that I control. Okay, so I can do that if I come over here, if I'm focused on the text box, I can come over here and there is a property here called multiline, and I can change that property to true. And as soon as that's true, I'll look at that. I can now make room for more than one line at a time to be displayed. Okay, good. So now we've got our text box all set up to be useful for this little demonstration. So I'm going to come into the click event of the Go button, and let's do this. I'm going to create a couple of strings, string 1 and string 2. And string 1 is going to be the quick brown fox, and I've got it ending with a space, and string 2 is jumped over the lazy dog. Okay, well, let's see what happens if I want to put those two together as a single message in my text box. Well, let's take the text box text property and set that equal to string 1 concatenation operator string 2. Now, the old plus sign is also supported for concatenation. That's an alternative equivalent operator. It's a little bit older. I like to avoid that one because there is no confusing the concatenation operator saying I'm working with strings with the plus operator, which is arithmetically combining two numbers, and that can cause some confusion and silly errors if we let it. So a little bit safer and smarter to use the concatenation operator. Let's try this code as it is and see what that does. So let's hit F5 to run and go. The quick brown fox jumped over the lazy dog. And notice that the quick brown fox, I left a trailing space, and so it's spaced properly here. If I had not done that, if I had not left this trailing space, the concatenation operator just sticks the two together, starting at the very end and the very beginning. End of the first and the very beginning of the second. So if I had done that, notice I get the quick brown fox jumped over the lazy dog. And I don't know what fox jumping is, but it sounds rather acrobatic and maybe a little bit difficult. I'm not going to attempt any fox jumping. All right, so I'm going to put the space back here. Now, what if I would like to have these two strings break right as I have them here and appear on two different lines? Well, the thing to understand about PC architecture is that a new line is actually composed in the PC operating system that of two different characters, a carriage return and a line feed. The carriage return returns the cursor to the beginning of the line. The line feed moves the cursor down one. So to get a new line, we really need to do both. That's PC architecture. And so old school, for doing that, there was and still is, a constant declared in VB, a reserved word, VBCRLF. And that is the Visual Basic carriage return line feed pair. So this generates a string of two characters. Okay, and does that work? Well, let's give it a try. Hit F5 and run it and go. And yes, we get it broken on two lines. The quick brown fox carriage return brings us back to the beginning of the line, and line feed brings us down one line, and then string 2 is expressed jumped over the lazy dog. And that's cool. And so you got to go, well, what's wrong with that, Professor Beck? Well, really nothing is wrong with that, and that continues to be supported for backwards compatibility. But here's the thing. It is now possible to run Visual Basic on other platforms. It is now a cross-platform product, and not all platforms have this hang-up of using two characters to denote a new line. On what we used to call big end or big endian systems, we just use a new line character, a single character, and it doesn't need both. As a matter of fact, if you use both, you might actually end up with an extra line feed in the mix, and so it's very confusing. So we really, since we might be doing cross-platform development for a Linux system or a Unix system as well as a PC system with our VB code, we need a symbol that will be interpreted by the .NET framework correctly for whatever platform the code is currently being compiled on. Whatever it's being built for, it's going to just work. VBCRLF won't do it. Okay, so there is a set of control characters, and in that set is a really nice, the control characters object has a really nice property called new line. And what is so cool about the control char's library implementation, this object implementation, is that for a small endian platform, small end platforms like the PC that use 2 characters, it will generate a character return in line feed. And if it is compiled on the .NET framework for the Linux or Unix platform, it will generate just the correct new line. And whether that's 1 character, 2 characters, it's all going to depend upon the library that you're compiling to, which is presumably going to be appropriate to the platform you're building for. And so this is a more universal way of doing things. And that's kind of, I think, instructive to see how we maintain backward compatibility. There's a lot of code out there developed for the last 10-15 years for VB that may have done it old school, and now we have a new school way. So the old school way is still supported to be backward compatible with thousands of lines of code, millions of lines of code that have already been written. But if we need the new functionality, or as we're going forward, best practice is to use the new method for doing it. And let's go ahead and test that, F5, and see if that still runs correctly. And go. And yep, visually, and on this platform, it does generate the identical result. If we were building on a different platform, we would still get the desired result, but it would be building it with the appropriate bytecode for the platform. So if it doesn't need carriage return and line feed, if it just is generating a single new line, that happens for us automagically, and we don't have to worry about it. So pretty nifty. So to sum up, we have multi-line property on text boxes, and we have the concatenation operator, ampersand, and the plus sign is still supported, but can be confusing because it could be confused with the plus operator, the arithmetic addition operator. So let's use the concatenation operator, best practice and new school for concatenation, and control characters dot new line to generate the line break. One other thing that can be kind of interesting is that if we are generating really long statements here, there's one other sort of new line related thing, and that is the line continuation operator. If I put an underscore in my source code and enter, then it will break the line so visually in the editor, but it's not seen this as a new command. It sees that as a continuation of the existing command. And so another take on dealing with lines and line breaks in VB, this one for the source code. So again, if this was getting really long, because you can imagine that some string expressions could get very, very long, and I'd be scrolling for miles horizontally, which is never a good thing to do, a lot of horizontal scrolling. If I need a little more screen real estate, I can break the line with an underscore, press enter, and then it will be recognized as just a line break, and it says this is not one command and this is a second command. The compiler will recognize that this is a single command. So bonus lesson. There we go. All right, let's leave it here for now. Here's a fun little program I think you're really going to enjoy because it does some things a little bit differently than we've done so far, and will allow us to explore some other approaches to managing the user interface while we look at comparing some strings. So here I have a text box. I've named it text first. I've got another text box, text second, and I've created a checkbox here. And a checkbox is a Boolean or binary control. It has two states, checked or unchecked, and I've labeled it matched. And what we would like to do is set it up so that this matched text box will always display checked if whatever we enter in the first text box is identical to the second text box, regardless of whether we change this one or this one as we're making changes. We just want the match to turn the check on or off. We also don't want users to manipulate it themselves by clicking it, and so I've gone ahead and marked it as disabled, or I set the enabled to false. So notice that there's no go button, there's no calc button here. So we need to be hooking events other than clicking a button. There are many other events other than clicking a button that we can get into. The first thing that I would like to do is when this form first loads up, my expectation, if this is blank and this is blank, those should be matched. And so it should set the checkbox to true. And that we can find on the form load event. And what we're going to do is when the form loads, we're going to call this little subroutine test for match. Now, I could put the code to test for match right in here, but because we are going to be testing for a match on many different occasions, when the form loads, when a change is made to the first text box, when a change is made to the second text box, all kinds of things are going to cause that same code to execute. So rather than having multiple copies of the whole long code around, I thought we would put it in its own subroutine. And so we're looking ahead at a technique you're going to learn soon in creating subroutines and functions that can be reused. And so let's take a look at what I've coded in test for match. So here's the test for match subroutine, and it's really not that complex. So anytime we call this test for match subroutine, it's going to look at the text of the first text box and compare it to the text of the second text box. And we compare string values exactly like we would numeric values using the equal sign in the context of an if. So if tells us that we're not doing an assignment, we're doing a test of equivalence or comparison. And the other thing we need to remember about text is because we have upper and lower case, and we might think of capital THE as being equivalent to lowercase THE or capital T, lowercase he, that's not true. Those are very distinct values, and so we only want this to be true if they are exactly matched, okay? And so that also suggests a problem we may have if the users are not thinking about case sensitivity and how do we compare that. We'll get to that momentarily. But to start with, test for match is going to say, hey, if these are identical, then set the checkbox matched value to checked, turn the check on, make it true, and otherwise make it false, turn it off, okay? And so we're going to call this when the form first loads. Let's just see if that much of the code is working. So let's press F5, and it's ghosted out because, or grayed out because it is disabled, but you notice that it is showing that yes, they are matched. Okay, so when the form loaded, it changed the default state of that. And I could have set the design time setting, the initial setting, to make it checked or unchecked, but I left it unchecked. So here's the proof. So it is currently unchecked. And when the form loaded, it says, is nothing equal to nothing? Yes, nothing is equal to nothing, and it checked that. So that appears to be working. So without the go button, how else, what other events can we hook so that when a change occurs in either text box. So when this one changes, if it makes it different, unchecked. If we make a change that makes the two equivalent, makes them the same, then make it checked. We also need to hook that here. So both of these text boxes have each their own changed event. And anytime there's a change, either in this one or that one, we want to call that same test for match routine. And that's exactly what we've done. So how did I find, by the way, if I come over here and double click it, it turns out this is the default event for finding text changed. And so it generated it for me. But had I wanted one of the other events, so what other events are available on the text first text box? If we look up here, this is the name of our project, this is the control I'm working with, and these are the events that are available. So if the tab stop changed, if the text align changed, if it's validated, validating, visible, all kinds of events. Oh, there's tons of them. Look at all the different events that we could hook depending on what we're trying to do. But really what we're after here is anytime there is a change on one or the other, call test for match and see if they're equivalent. And let's see how this is working. So I hit F5 to run it again. Now nothing is equal to nothing, and so they are matched. And I'm going to start to type my name, and as I type it, notice that it immediately turned that off because I made a change here. I didn't need a go button to make it happen. ON is not the same in the second text box. But what if I add a J there? Nope, still not matched. How about O? Nope. How about N? Ah, now they're matched. But if I keep going, space BEK, it's unmatched, unless I come over here and say space BEK. And now it's matched again. Cool. Okay. Well, what about this case thing? So let's just put a single letter, capital A there. Capital A there, they're matched. What about a lowercase a? Not matched. Uppercase A does not equal lowercase a in the same way that William does not equal Bill. You may know that your cousin Bill is William and William is Bill, but when he's called William, it's because he's either in a business suit or he's in big trouble with grandma, or otherwise he's Bill. But the computer says capital A and lowercase a, totally different things. William is not Bill, and so unless they are identical, either both uppercase or both lowercase, then they're not a match. Okay, well, this is potentially a problem because, do we want to be that rule bound with users who may kind of get it wrong? No. Okay, so there's a couple ways we could deal with this. One is if we really want to make sure that we're all uppercase or we're all lowercase because we're going to save this data and it really needs to be consistent, we can fix that. And so one of the properties on our text box that we can explore has to do with the casing of it. And let me check my crib notes. And I've forgotten what the property is. Oh, character casing, of course. Okay, so if I come over here and look into the character casing property, I can change this so that it goes everything to uppercase. And I could do that here and change the character casing to all uppercase. And so having done that, now if I run my code and I try and type lowercase letters, wait, it's forcing uppercase. I can't type a lowercase letter. So even on my keyboard, you can't see my hands right now, but whether I hit Shift J, lowercase o, Shift N, I can't generate that. And so it is forcing them into all uppercase, which takes care of the match for me. And now if I save these text values that were entered, they will save as all uppercase. Okay, I can similarly do the same thing, making them all lowercase. So I can change the casing normal, upper, or lower. So I can make them all lower. And now, just as you'd expect, if I try capital J, lowercase o, capital N, it's forcing it, it's converting it to all lowercase. And so this is a good way to help some data entry consistency. It goes hand in hand with data validation to help protect and control the consistency of the data entry. And so that works. But what if it is objectionable to have to do all lower or all uppercase, but we'd still like to test if there was a match intended? In other words, we'd like to have case insensitivity. Is there a way to do that? Yeah, there is. Okay, so first let's turn off the character casing here. So we're going to go back to normal. And on our second text box, let's change the character casing to normal. And let's test it, make sure that's working correctly. So here's mixed case and here's mixed case. And yeah, they're identical, so they match. If I make it capital O-N, they're not matched. All right. So what if I wanted to preserve however the user originally entered the casing, but I'd like to test it against a string value and ignore everything except the spelling? If they're identical in spelling, even if there's upper lowercase differences, I don't care. How can I do that? Okay, so let's take a look at how we would modify the program to do that. So let's go into our test for match subroutine. And right now, the test for match subroutine is saying, you know, if the text for the first and the text for the second are the same, then we're matched. Okay, let's get this out of the properties and put this into some variables and use good form here. So let's say dim text first string as string, dim text second string as string. And I notice I misspelled this, so let's fix that. And then let's come in here and say txt first string equals txt first dot text, and txt second string equals txt second dot text. Okay, and one of the things this is going to allow me to do is now I can play around with these variables without changing what was actually entered here. Okay, and so let's change this over to compare on the variables. So txt first string equals txt second string. Then we do that. So txt second, second string, not quite right. Okay, so before we go further, let's just see if our original functionality has now been preserved when we're working with variables rather than with the object properties directly. Okay. Yeah, okay, so that seems to be working just fine. So here's what we can do if we want to make it case insensitive. We could say, you know what, whatever they entered in the first string, force it to lowercase and force it also to lowercase in the second variable. And now, because we're changing the variable value, casting it all to lowercase in both cases, then even if they start out having different cases, as long as they're spelled exactly the same, it should work. Let's give it a try. Okay, so JON. Now, JON is what we're seeing on the screen because that's the text box text property, the object property. And let's type JON here. And notice now this is lowercase and this is matched, even though they are not identical because of casing. What about if we spelled it differently? As soon as it's spelled differently, it departs. It's no longer matched. But all uppercase still matches. Doesn't matter how it's cased. It could be case it real crazy. And that matches because the variables, and let's go ahead and set a breakpoint and see that actually working. So I'm going to set a breakpoint over here at the end of the if, and let's run this. Okay, and this is going to fire a lot, so we're going to break a lot. And I'm going to continue running it so we can see the thing go. In, and it breaks, and I'll continue running it, and we're not matched. And let's put this one in all uppercase J. Run again, continue to run, capital O, continue to run, capital N. And now let's take a look and see what our watch window shows if we add the two variables, txt first string and txt second string. And notice that the value of the variable is still preserved, but if we were to look at it as to lower in each case, which is what we're evaluating here, txt second string to lower, so even though they start out having different case, when we compare them when they're cast to lower, they now match. Cool. So we could play that game by casting them all to, or converting them all to uppercase or all to lowercase, just so long as we're consistent, we can test for a match. And let's go ahead and tell this to continue, F5. And notice that the original casing is preserved, even though we're able to compare it and get a match. So, there we go. Let's recap here. So one of the novel things we did here was we used the checkbox not as an input, but we actually used it as an output. We had disabled it so that the user can't actually manipulate it, and our code is doing it. We hooked the change events on these two text box and also the form load event to every time any of those events fired. If this one gets changed, or when my form first loads, we're calling a common subroutine. And again, we could have put the logic for test for match. We could have taken this whole thing, right? Everything that's inside this subroutine, and we could have copied it here, and we could have copied it here, and we could have copied it there. But think about that. If we want to make one little change, we've got 3 places to change it. So we made our own routine, almost like having something built into the language that we needed, and we just called it each time. And that way we have one common shared body of code to change if we need to modify anything. So That's a little bit advanced for this point in the course, but it's kind of fun to see where we're going. And this is really kind of useful and powerful. And I don't think it's too sophisticated at this point for us to understand. And then we explored a couple different things. On the form itself, we looked at the text box property for the character casing. So there's a character casing property. We can force it to uppercase. We can force it to lowercase if we want to, or we can do the comparison without modifying it at all using the string property to lower or to upper. All right, let's leave it there. Let's explore the concept of pseudo-random numbers on computers. And so to do this, I've got a form set up. I've set up a text box and expanded it out really large and made it multi-line. I've got two buttons, a go button and a clear button. And the clear button, all that's going to do is clear the text box between runs of our program. And the go button is what's going to call the function to create random numbers. And I want to explore that with you. But before we get off on that, we need to talk about the concept of random numbers. So the whole basis of digital computer design is to make predictable finite state automata, a finite state machine that will always give the same answer for the same problem. And hopefully that's the correct answer. But we absolutely have to be consistent. And so the idea of a computer generating a truly random number is kind of antithetical to the whole premise of all of our engineering and design that went into the computer. So long and short of it is, unless we create some sort of special device or peripheral for our computer that truly is going to track and generate a number based on some random event, we don't really have truly random numbers in computers. What we have instead are pseudo-random numbers. So we can create a complex mathematical function that will give us a continuous sequence of numbers that, depending on what we use to start that function, we could start it at the beginning or in the middle or 100 million integers down the line into feeding numbers into that function. And from one number to the next that is generated as the answer, it will look like it is pretty arbitrary or pretty random. The problem is that's based on a definite mathematical function, which means the same inputs will always generate the same outputs. And so what we need is something that will start our function in some way a little bit differently, at some different portion in the series in its sequence of numbers every time we run it. And so we'll have to think about what that can be. But just to prove the point that this is not truly random, I've set up this program. And so let's just walk through and see what it appears to do at this point. So we are declaring a number as an integer, and I've got declared an integer variable I, and we're going to use that for a loop counter. And we haven't really worked on loops yet, so bear with me as we kind of look ahead. And then we're creating a random object. Excuse me. So there is a random library, and we can create an instance of the random class, and I'm just going to call it randgen. And so in my loop, which I'm going to repeat 1,000 times, we're going to do the following. We're going to set number equals to randgen, the next random or pseudo-random number in the sequence, and we're going to scale it so that the value is always going to be between 1 and 100. Now I've got that set to 101, and that is because the upper end of the range is exclusive, meaning it doesn't include the value specified. That's a story in itself, but it's done for legacy purposes. Gosh, wouldn't it have been nice if we want a number between 1 and 100 and we had something straightforward like saying, hey, give me a number between 1 and 100. Yeah, long computer science story, which we'll skip for the time being, we specify one more than the value that we want because it's exclusive of that. It'll be less than 101. All right, so it generates this pseudo-random number, and then we are going to take it and we're going to um, place that number, concatenate that number, followed by a comma and a space, and we're going to take that along with whatever the existing text is of the text box, and we're going to put that in the text box. So what that means is every time it goes through the loop, it's going to, for 1,000 numbers, it's going to add, or I shouldn't say add, it's going to concatenate or glue onto the end the next number. So we're going to get a string of 1,000 numbers. And let's see how that works and whether we're happy with that. So we press go, and it takes a moment to generate that and then refresh the screen. And here are 1,000 numbers, or at least as many of the 1,000 as will show on the screen. And does our clear button work? Yeah, that seems to be working fairly well. Okay. Now, here's the thing. In order to not get the same sequence every time, we need to provide a different seed, a different starter position on this complex mathematical function that we're calling random, but is really pseudo-random. Okay, and just to show you that the numbers are not truly random, I'm going to put a specific value in for the seed. Now you would, in practice, you really would never want to do this, because what this is going to do by putting a specific number in there, that is always going to initialize the random object sequence using a coefficient or an offset of 2468, which means that although these 1,000 numbers in a line look pretty random, they don't seem to have any relationship with each other, they are always going to be generated off of the same sequence, which means that I'm going to generate the same pattern every time. And if you were a poker player or a gambler, how many times would you have to see it before you go, hey, I recognize a pattern here. Let me just spend a night on somebody else's money instead of gambling. I'm going to write down what I see as the sequence, and then I will know what number is coming up next. I will know what card is going to be dealt next. And let's prove that this is true. So let's go ahead and run this again and press go. And this is a lot to take in. So let's just look at the first few numbers. 8, 98, 88, 34. 8, 98, 88, 34. Let's clear it. Let's run the function again. And if what I'm saying is not hogwash, guess what we're going to see? Oh, 8, 98, 88, 34. Uh-oh. So although this sequence of numbers seems to be arbitrary and random, again, it's really being generated by a mathematical function. And so that coefficient or that offset that we're starting with, known as the random number seed, we need to change that every time. And we need to change that over a domain that is variable enough and large enough and unpredictable enough that it is not likely that a human being is going to rapidly be able to recognize it. Okay, and in some cases we need to start thinking about whether a human being who might be augmented by some sort of cheating device or digital device to help, capture or recognize, figure this out. How do we make sure that even a really smart computerized device can't recognize it? And that gets to be a little bit more complicated. But let's see what happens if we don't put a value in here. Okay, so when we don't provide a value, a slightly different version of the random seed event occurs. So what it's going to seed on, it's going to go look at the system clock on the computer, and it's going to look typically at a value like that the system clock can give it, such as the number of milliseconds since midnight. Now, boy, you'd have to be really precise with you click off the mouse, and you're very patient to wait 24 hours, exactly 24 hours in however 24 hours times 60 times 60, 24 hours times 60 minutes times 60 seconds times 1,000 milliseconds. You need to hit it right on the drum beat in order to generate exactly the same seed. So it's pretty unlikely that in a 24-hour period we're going to come up with the same seed. And actually, if we needed to go further than that, we could introduce not just the milliseconds since midnight. We could go milliseconds since the the first of the year, or since the turn of the century, or whatever, so that we could make that more likely to be unpredictable or unguessable or unduplicable. Okay, so by leaving this blank, we're actually going to get a slightly different version of the initialization on random, and it's going to automatically provide the time for us. Once upon a time in computer science and the evolution of computer languages, including BASIC, we might have actually gone and parsed the system clock or done something else to create a seed to randomize it. But let's see if this is now doing the job so that it appears to be more random. So with it using the time on the system clock, milliseconds through since midnight, is this going to give us a more random run? So I said F5 and let's go. And on this run, we got 93, 95, 91, 59. Okay, 93, 95, 91, 59. Let's clear it and run it again. Ah, and this time we got 34, 11, 5, 99, and the rest of their friends there. Okay, so the difference is that when I started that first run, there were some number of milliseconds since midnight. And when I ran the second run, well, time had passed, so there were more milliseconds. So it started with a larger or different number seed, which means that it's returning a different portion, a different sequence set on this complex mathematical function that is giving us the pseudo-random numbers. Okay, so good. So now we understand that, number one, there aren't truly random numbers in most computers. If we really needed to make a device, we might be able to do so. That would give us something that was closer to truly random. But generally speaking, that's expensive and not what computers are equipped with. So what would such a device look like? I don't know. Let's imagine that you could take a sensor that measured the temperature or the average kinetic energy of molecules bouncing around a really hot cup of tea. And so, if it was really precise, it's really unlikely that a big, large, tall glass of hot tea is going to be at exactly the same temperature. So it's going to have a different amount of entropy, a different thermodynamic. And so, yeah, we could use that as the basis of our seed. Kind of elegant and maybe a bit poetic if you like authors like Douglas Adams to generate the random number off of a hot cup of tea. But kind of complex and unnecessary, since we can do something so effective using just the computer clock, which all computers these days have, and the existing pseudo-random number generator. All right, so let's look a little bit further at our code before we go on. And let's play with this. Let's reduce this down so that we're only getting, because we haven't really learned loops yet. So I'm going to go ahead and knock out this for next loop. And we're just going to generate a single random number. And you know what that probably means. We don't really need to have this be a big multi-line text box. So let's turn the multi-line false, and let's shrink this down to a more manageable size. Doesn't really need to be that large. Matter of fact, let's take our whole form and make it a little bit more manageable. Okay, that's a little more like it anyway. And then let's go in here and let's see. We don't need to do all this concatenation stuff either, so let's simplify here. And just put the random number in there. Let's see how that works. And clear, and go, and clear, and go, and clear. Nice. Okay. So again, we can set our numbers up, our range, to just about anything we like. This first number is the lowest number inclusive of the numbers it will generate. And this is the highest number. So right now I'm generating between 1 and 100. And yeah, I know it's confusing that this is 101 and this part is exclusive when this side seems to be inclusive. Deal with it. It is the way that that VB works, and there are legacy reasons for that. I'm not defending it as being good reasons, but that's how it is. Okay, so let's prove to ourselves that this upper range is exclusive. So if we said find a number between 1 and 2, let's go ahead and see what happens. So 1 to 2, except I said 2 is exclusive, so it's really between 1 and 1. So I generate 1, I clear it, and 1, and 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 oh, so it's really that is a range from a random number between 1 and 1. Is not terribly random, is it? Okay, so if we want a number between 1 and 2, we need to make this 3, and let's run it. Okay, 1 and 1 and 1 and 2. Okay, so I finally did get a 2. And I should get a 2 about half the time statistically, but in no predictable sequence. So if it's a good and true mathematical function with random distribution, or if it approximates random distribution for randomly generating 2 digits, about half the time I will get 1 digit, about half the time I'll get the other. And the math that helps you to know that the random or the pseudo-random function has that property is interesting, and I commend it to you, but it is well outside the scope, happily, of this class. So we're just going to trust that that's the case, and we're going to learn to use the random function. Okay, so this is between 1 and 2. Could I, if I wanted to, have it be between 0 and 2? Well, let's try it. Go, and there's a 1, and go, and there's a 1, and go, and there's a 0, and go, and there's a 1, and go, and there's a 2. So yeah, I seem to be getting the full range there. Can I have negative numbers? So between -5 and +5, which is to say I put a 6 in there. Does that work? And again, I encourage you to, when you have these kinds of questions, I mean, these questions should occur to you. You should get curious about these things. Best way to find out is try it. And then after you see what you see when you try it, then go look at the documentation, and that will really cement why something works the way it does. So yeah, the negative range works as well as the positive range. So that also means that it should be very easy to say, I want to generate random numbers, but only between the range of 90 and 100. And again, got to kick this up one above because this is exclusive. And run it again, and should be getting numbers only in the range 90 to 100. And it does appear that I am getting that. Okay, let's look at this one more time. And so we're using a little bit different initialization than we have before, and this is common with objects. So rather than just declaring rangen as random, we're creating specifically a new random object. Okay, so this rangen is a brand new object instance all of itself. Why that would be really handy is we might want to create multiple random number generators, and if we create new object instances each time, they're each new and separate one from the other, and we're ready to go with all the properties as a standalone instance, and destroying one instance or getting rid of one if we're done with it doesn't have any impact on the other instances. And so this is just a little bit different convention than what we've used for most of our variables so far, but it's quite common when we're generating instances of objects and then working with them. All right, so again, just to see it, if I wanted to range from 0 to 10, I would specify 0 to 11. If I wanted a range of 1 to 25, I would put in 1 to 26, and that's how I control the range, generate the random number. If I do not provide a seed, when the program runs, it will take the time generated at that point. So think about that. How secure is that? Would it be possible to make another program that runs this program, but only allows it to run at a particular time, so we could force the seed to generate with a known quantity? Conceivably, yes. Okay, so this is not perhaps the strongest security, but it will do for most purposes. But it's good to understand a little bit about how the random or pseudo-random number function generation works, so that you know in what ways you can trust it and depend on it, and in what ways clever people might seek to undo you if you ever end up programming electronic gambling simulations for somebody in Las Vegas, or you need to generate truly random values for security keys and things like that. You can keep in mind the way in which these sequences might be guessed and how the system might be gamed. And I think we'll leave it there for now. This concludes the lesson.